Hi everybody, welcome to today's session. This is session 4, stacks and queues of CS32 interview, CS32 technical interview track. Sorry for making a mouthful. Let's get started. So today's portal code is pop and lock. I could not think of anything else, so I'm so sorry. And also I know I had really cringy description for today's session. Just don't mind me, I'm just trying to spice it up. Unfortunate. So once you're done, we're gonna wait for like 10-15 seconds so you could get the portal code. And don't worry if you I guess don't do it. I think the prize is probably going to go to Tyler Fung anyway. Shout out to him right here. In this video. Okay. Okay, let's go on. So here's a link. I already pasted it in the chat. I'll do it again just in case someone else comes in. So follow along, obviously, and let's get started. Please work. Here's our just feedback form if you're so kind to drop something afterwards. So yeah, let's get started. So we're gonna go stacks first. We're gonna go over some stack. I was gonna say overflow, but then that's just a website. Okay, let's go over the overview of stacks. As you all already know, you already learned this probably 2 weeks ago or a week ago. But basically, these are containers that you can insert and remove as per the special rule. It says it's like last in, first out is their principle. So basically, the way we describe it in real life is that you have a stack of books, and then you can only remove the topmost book every time, and that's going to be your pop function basically. And so as the functions you've already known, especially because you've already done homework on this, you can add elements to the top. You can look at the element at the top, which is just top, as well as popping from the top, as well as checking if the stack is empty. Any questions? Oh, I also forgot. Well, we were supposed to poll if you are comfortable with stacks and queues. Just because I might go a little bit faster, just if you already know stacks and queues, you guys already know stacks and queues. Great. Awesome, we're all comfortable. That's always nice. That means that we could probably, breeze on by with the questions, which would be great. Okay, so we got 11 out of 12. Awesome. I don't know why. So sorry, I didn't change the last poll. It's supposed to say I'm a stacks and queues master instead of a linked list master. I'm very sorry that I didn't put that. So forgive me. Okay, so results are in. Looks like we're all really familiar with them, and that's always nice. So I'll just go pretty fast and not waste a lot of time on stuff that isn't right. So as you guys already know, these are some of the operations that you'll be doing with a stack. Always include stack, that's going to be your STL, and basically using namespace std, or you can just do std : for all these functions. As always, top, be sure to top before you pop, just because pop is a void function, and top would get you whatever the element is at the top. Very nice. Obviously, these are the visualizations for a stack. Very nice. Pop, you push, when you push, you have to pop from the top. Yep. Okay, so we're gonna go with time complexities. Since you guys are already masters of stacks and queues, anybody want to give me the broad sense of what the time complexities are? Insertion, deletion, what's another one? Search, and then access. Slides say you need access. Great. Oh wait, I think I set it to UCLA students only. So check if you are logged into your UCLA account. Yeah, okay. So can some people see the slides? Can I get a thumbs up if you guys can see the slides? Works for me. Okay, sounds great. So I think I set it to only UCLA students, unfortunately. So see if you can just drop down from your Google account and log in from there. Okay. But anyway, any kind soul would like to tell me the time complexities of these basic operations that we're supposed to be doing? Okay, all of one. Great. I think that's pretty much the gist of it. We'll go further, but basically, yeah. So Insertion, we're going to be 01 because we can only insert from the top anyway, so there's no need to like insert in the middle or something where we take O(n). But in this case, everything's 01. Deletion is also 01, except for access. So if we want to access a specific element, and obviously like if it's on the bottom of the stack, then we're actually going to have to go through n number of pops in order to get to the element that we want. So that's going to take at worst case O(n), as well as searching. So for searching for a specific element or searching for a specific value, that's also going to take O(n) at worst case, just because, you know, as I already said, O(n), if it's on the bottom of the stack, we have to put pop them all the way. Okay. So implementing a stack. So I think Naschenberg and Svalberg are probably already touched upon this, but I just wanted to give a little bit more of an overview. Basically, you can have either array-based implementation or a linked list-based implementation for both a stack and a queue. And so from the diagrams on the right, so you can see that we are keeping track of two variables in an array-based implementation, so that you have capacity as well as top. And if top exceeds capacity, then, you know, we'd have to either resize or, you know, throw an exception. And usually, I would say most, like 99% of the time, you would probably just increase the size, and most of the time it's going to be doubling the size. But this is, you know, you have to take into consideration that if you were to double the size, you're going to have to, you know, copy everything from your old stack to your new stack and array. So that could, you know, come up if you're in a technical interview. It can be like, what's some trade-off between, you know, an array-based implementation as well as a linked list-based implementation. But in any case, if you were just coding, I would just use the STL. Okay, next up, linked list-based implementation. So dynamic in nature. So there is no like size feature that we have to keep in mind. And as well as every node, we would just, you know, set it to the beginning of the linked list. So as you can see from the diagram, the top would just be there. And then we would, every time we insert a new element, then we would just you know, have a next pointer to the current top. Sounds good. Any questions? Awesome. Okay, let's get moving on. So nice meme, you know, just because although that was a little bit of information, I am sure you guys already know. So corn, and we're gonna pop it. So it's popcorn. Haha, it's so funny. Week 6, I'm dying inside. It's okay. Next up. Okay, so stacks are really fast. So let's go to queues. Just like I said before, with a stack, queue is a container of objects that are inserted and moved per the first in, first out rule. So that's different from last in, first out. You guys already are pros at this. So basically, you know, useful abstraction, real world example, queue at a line, queue in a line in a restaurant. You know, you don't serve the person who comes last because that might be weird. You always serve the person who waited longest, etc. So permitted operations, once again, adding elements to the back of the queue, accessing from the front of the queue. So you're going to be like, you know, removing from the front, popping from the front, as well as checking if the queue is empty. Okay, so these are just basic operations once again. And here are the operations. And then, you know, include, constant include, queue, always, STL, very easy. And all these functions, I'm sure you guys already know what it is. So time complexity, this time, I know you guys are so smart, so we're just going to go through it. Well, it's O(1) for insertion, O(1) for deletion, and then access and search. Just like what I said before, you know, if it ends up being at the end of the queue and you can always only remove from the front of the queue, then that means that at worst case it would take O(n) for both access and search. Okay, so sounds good. Implementing a queue. So unfortunately, I don't have a diagram for this one, but basically the same thing as a stack. You can either implement it an array-based implementation, or you could do a linked list-based implementation. So if you were to have an array-based, remember that you'd also keep track of two different, like you would keep track of the front of the queue as well as the end of the queue. And when you insert, you would insert from the back of the queue. So you would just increment your indice once more. And then when you delete, you would just like decrement. And then similar to a stack, we have a size limit. So most cases, you wouldn't be doing just like a static array. You would be, it's probably a circular buffer, but like that's beyond the scope right now. And then also, so just basically we would either throw an error or increase the size of the queue. And obviously, like I said before, you'd have to copy everything from the current queue to the bigger queue. That's going to take some extra memory. Okay, linked list, once again. Okay, if we're going to do just a regular old queue and you can only insert from the back and you can only remove from the front, then it's a singly linked list. So dynamic, there's no size, just like a stack implementation of the linked list, I guess, linked list implementation of the stack, sorry. We can also add and remove nodes just as we want. It's just that, you know, every time we do make a node, that's going to take some time. It's going to take extra memory, and these memories are not contiguous. So think of this when you maybe one day you do have to implement your own stack in queue for some reason during a technical interview. I'll be able to, you know, explain the thought process of like why you chose an array-based implementation versus a linked list implementation. So like I think Smallberg and, you know, Naschenberg probably already touched upon this, but basically like linked list, you know, they're not contiguous memory. The pointers could be anywhere in the stack that you created, and then as well as, okay, so an array-based implementation, it would be one contiguous like block that you what's it called, you allocated, and then so if you were to, you know, get a specific element like from the front, then you could cache it. You guys might not know this right now, so I will just gloss it over, but basically be able to explain your thought process between implementing which version. Any questions? Nice. Okay. So this time we're going to actually go over some different types of queues. You know, this is a big hint for later on in the questions that we're going to be giving you. So we can have, so like obviously we have a regular old queue, which you can only insert from the front and also remove from the this tail or back. But in our case, you can actually have a dequeue, which is a double-ended queue. So C++ already has this standard library template for this. I would say standard library, yeah. So basically, you would just # include dequeue instead of queue, and then elements can be added or removed from either the head or the tail. So that's always nice. And then a circular queue. So in a circular queue, that means that we can utilize the, like in this case, it would be an array-based implementation, right? So you would be able to utilize the maximum number of the size that you actually allocated, because like in our diagram on the bottom right, you can see that if we were to increment once more, you know, we add someone to the back of the queue and then back increments from 4 to 5, and we want to increment, we want to queue another person, then we would technically be like, oh, we don't have any more space because it's going out of bound. But in a circular queue, we could actually, you know, go like in a circle, very funny. You can loop around and basically do, you can let index 0 be your end of the queue, and you just have to keep track of where your back and your front is. Does that make sense? Very nice. Okay. So when would you want to use a stack versus a queue? So most of the time they're very similar. So it depends on just how you want to implement it. But basically, some of the key points to note is that they both maintain order, which is nice. So when you remove, you always just remove, you know, for a stack, you always remove the like last element, and then a queue, you always remove the first elements. And then you got, I'm not sure if you guys learned depth first search algorithm and breadth first search algorithm yet, but for a stack, you would use a depth for depth first search algorithm, you would use a stack, and for breadth first search, you would use a queue. Oh, so, and then I think you've already done this in lecture, but basically you can parse infix notation into postfix, or you can just parse it in general and and get an answer. So these we would use stack, as well as, you know, throw back to session 2, we reverse the string. What's easier to do that than just use a stack, because everything is last in first out. Nice. And then so as well as backtracking. So you'll learn about backtracking a little bit today, but basically you're just going to be, I guess, exploring all of the possibilities of, you know, a solution and trying like I think that's a good way to put it, just like trying to explore all the possible ways of getting a solution. Yeah, sounds good. But in that case, you can use both a stack and a queue. Depends on how you want to implement it. And I think a good world example of using a stack in real life would just be like undos and text editors. So you can undo what you had, what your last command was, and that's a stack-based implementation. Yay. But then also remind yourself that, you know, there's only so much you can undo. It's kind of like a stack having a specific capacity. Nice. Okay, on the queue. So like I said before, it's breadth first search algorithm. That's awesome. But then also it's actually used a lot in like operating systems. So it's great at handling system interrupts. So which interrupt comes first, we would handle that first, right? And then also as well as job scheduling. So you always want to accommodate, whoever like CPU workload came first, but that always is like kind of different because some jobs are more important than others, so you have to keep track of that as well. So in that case, we would use a priority queue, but that's not really a queue at all. So you don't have to worry about that until later. Sounds good. Just wondering, would dequeue be the most useful since it seems to have the functionality of both stack and queue? Nice. I'm glad you noticed. But basically, yeah. So in most cases, if you were going to have to do a stack or a queue on a technical interview, if they don't explicitly say like use a stack, I would just use a dequeue because you can remove from the front and the back. It's very like flexible in that way. But if they're like, oh, use a stack, then you have to pound sign into stack. And actually, Bill actually reminded me yesterday. Oh, not reminded me, but he informed me yesterday that stack and queue are built on dequeue. So basically, it's just like a limited version of dequeue when you have a stack.
I mean, yeah, specifically in the C++ standard library, I think.
Right.
I think different implementations could be different, I think.
Yeah, so only in C++, and I'm actually not sure if it's like which standard he's talking about. So please don't kill us if it's like, C++ 19 doesn't actually do that. So we're just like one of the standards. Nice. Okay. So nice meme just for, pat yourself on the back before we dive into something more. So very funny, I don't think anybody uses Uber anymore because we're in a pandemic. So this is, I guess, what is the word? I can't remember. It's just like irrelevant. Okay, so let's have a warm-up question. Valid parentheses. You'll see this question on the code as like, as a, I think like a quintessential stack problem. Hint, hint, basically. So hopefully it'll drive you, get your, coding skills ready again, and we can dive right into this question. So basically, I'll just restate read the question and restate what it's asking you. So we're going to be given a string and consisting of only these 3 sets of parentheses. And we're going to return true if the string is valid and false if it's not. So obviously you know what a valid parentheses is. So the inputs should tell you what it means to be a valid parentheses. So from our first input, you can see that they all match up to each other. And so in that case, it would be valid. But the second input, so the squiggle actually doesn't match up to a squiggle right before. So like, I don't know how to say this, but like basically the 2 closing brackets like have to be like when you join them together, it needs to form, wow, this is hard to explain. Okay, but basically just look at example 2 and 3 and see that when you look at it, I think it just makes more sense. But there are definitely different variations of this question. So in some cases you would have, the string would not only consist of, what's it called, these 3 sets of parentheses. They could throw you a curveball by saying like, oh, you can have any kind of character, right? So you'd have to be able to parse out the characters as well. And then as well as, some parentheses can be nested, and then like you can have different sets of parentheses. And so you have to test if the nested parenthesis expression is valid or not. These are all like good questions to familiarize yourself before a technical interview. So this is pretty easy. So I'm just probably going to start coding it up. So let's go on to Replit, and I'm going to copy this. Okay, thanks, Google. Okay, so here's the statement. And I've already created our nice function signature. It's not header. Call it, okay, so it's I'm going to call it verify parentheses, and I'm going to be passing a string called input. You don't have to pass in a string, and maybe it's passing a vector of characters. Either way, it's fine. I just thought it would be easier for me to pass in a string. Okay. So what's something that I have to watch out for, like maybe edge case wise that, could happen in this particular question? Don't be shy. Be sure to give me some feedback. More open than closed brackets. Yes, so that's definitely something we have to consider. And to quote CS181, I'd be like, I give you a token for that, but no tokens for you. So more open brackets. Anything else? So yes, empty string. Awesome. Color on a roll. And then, so good thing that we don't have to actually parse anything else except for, those brackets. So we don't have to say like, oh, what if there's a character like outside, like that, those three sets of parentheses. So that's something that we have to worry. Okay. So this sounds good to me. And let's get started. So obviously, pound sign includes stack. That's what we're going to be using. Then, yep. Okay. So first of all, let's have our stack. This is going to be a stack of characters, right? Because we're only going to be pushing on like one bracket at a time. So we can call this just like what I might be just going to just call it P stack. It could be parentheses stack, but I'm too lazy to type out parentheses. And then for each character that we're going to be picking from the top of the stack, remember that pop doesn't actually return you the top of the stack, so you have to peek at it with pop. So car, and I'm going to call it top. Okay, and so let's for int equals I to, oh wait, I equals 0, I less than, actually I'm going to call the length of the string outside just because technically it is like a small performance boost, because then the for loop doesn't have to call it the entire time. I think it's just question about length. Okay, so it's called a length, and then I press. Awesome. So what will we be checking in the beginning, right? So like our thought process is that, so we're going to be parsing from the beginning of the string. And so every time, when I see an open bracket, I'll be like, okay, well, I need that, right? Like I'm going to take in all the open brackets so that when I see a closing bracket, I'd be like, oh, if they match, then, perfect. Then they can like, go on a honeymoon together and like we can pop off the opening bracket, right? So in that case, let's, call input of I. So let's, I'll also just check that if it's an open bracket, right? Because in the beginning, it could also be a closing bracket and it would screw up your for loop. So if input will equals opening bracket, and we know we can have 3 sets of brackets. So input of I equals squiggle, as well as of I equals our square bracket. Okay, if we have that, then we should push that onto our stack, correct? So p stack dot push. I'm going to push. Okay, and then outside. So what if we don't see that? So that's going to be an else statement, right? So like else if. So we're going to be looking at possible closing brackets. So actually, I think that's right. Okay, sorry. Else if input of I equals closing bracket. So let's do this for everything. So if the input is a squiggle bracket, that means that the top of our stack should be an opening squiggly bracket. Does that make sense? Does that make sense? On why that should be? Because we're going to be popping in order. So obviously here I should probably say if top of the stack, right? So p stack dot top. I can probably move this outside. Hold on. I'll just call this just because I want to peek the top of the stack. Top or stack top. Okay. And top equals. That's good, right? So we'd be able to pop off the top of the stack, as well as, you know, the two other what's it called, patterns that we can have: square bracket as well as our nice squiggles. Actually, no, I already have squiggles. So this is just a regular parentheses. It's giving me yellow green lines, so I'm not sure what it doesn't like about me. Oh, yes. I should have caught my error, because this would be parsing really weird if I didn't have parentheses around this. So basically, these if statements should be, so the input of the squiggle and squiggle should be parentheses, so that when you and it, it's the correct parser, parsed by the compiler. Thank you for the compiler for catching that, actually. Okay, so in that case, if it matches, that means that we can just pop from the stack, right? So p stack dot pop. And then in this case, what if the input wasn't correct? So if none of these match, that means that, oh, it's probably there's a mismatch in parentheses. In that case, we could probably just exit early and return false, right? Because if we had a mismatch, that just means that the entire series means that it's not valid. Therefore, we can exit early. Very nice. So outside our for loop, like what Aiden said, more open than closed brackets. So let's think about that when we go through our open for our for loop, right? So like, if there happens to be more open or, you know, more closed brackets than open, actually no, it would only be open because we only append open. That means that, you know, we have what's it called, an uneven number of parentheses, and therefore we should return false. So if our stack is empty, and there's a handy function for that, so it's not empty, you know, that's not true, right? So we would do a negate, also return false. And then outside of that, you know, if it is empty, then default situation should be returned. All right, I keep on capitalizing true because Python, but anyway. Okay, so let's run through our code again and try to visualize if it's correct. So let's see. Okay, we make a stack and we're going to initialize. We're not going to initialize, we're just going to call our character top, call our length, and then for each character in our in our string, then we're going to check if the string is an open bracket of each of the three sets. If it is, then we're going to push it onto our p stack, and then we're going to look at the top of the stack. If the top of the stack is this, if the top of the stack is one of these sets, as well as the current input is a closing bracket of matching the top of the stack, then we should pop from the top of the stack, because that would be one complete parentheses and we don't need it anymore. If that doesn't happen, then that means that we have at least one kind of mismatch, and in that case, we want to return false. After that, so we loop through that for all length times, and then after we check if the stack is empty, and if the stack is empty, then we want to return false. and then else we should return true. So in this case, I didn't actually take into consideration of Amy's point of having a empty string in the first place. So let's take into consideration of that. So if length ended up being 0, just really early, right? We don't even need to run our for loop because it already works. Okay. Okay, let's test this function. It's always good to test. Okay, let's call this verified parentheses. Oh, why is it doing this? Okay, let's give it an input. Anybody want to suggest a string for me? Nice and easy. Anybody want to suggest a string? No strings, no strings. Okay, it's okay. I'm not sad. String, sad. Quarantine. As you can tell, I'm very sad in quarantine. Okay. And then in this case, I wanted to use what CS32 already uses, which is the cert library. So basically, as you guys probably already do this on homework and on the labs, in order to test your functions and of their behavior, you should do asserts. So basically, I hope you guys already know. Do you guys all know what asserts are? Because some people might not be in CS32, and I just want to make sure that I let them understand it as well. You don't have to type anything. You can just give me a thumbs up in the nice. Okay, 1 thumbs up. That's awesome. Great. Okay. So in this case, we would call assert and verified parentheses of sad. Oh, why did I say quarantine? This is dumb. It should be parentheses. I don't know why. I think I was just caught up with the fact that I was sad from quarantine. Sad. And then we're going to, this is going to be valid, right? So this should be true. Therefore, we can either do equal equals true, or we can just leave it as bid, but to make this a little bit more clear, let's just do equal equals true. Key. Oh gosh, it's saying that I probably have mismatched parentheses, right? Okay. Oh, is it these guys? Yeah, it's these guys. Oh, dang it. What did I do wrong? Okay, so in my case, let's see. Okay, so let's step through. Basically, I have my open parentheses. So if it is one of the parentheses and I push onto it, and then I look at the top, and if input is this and top is this, so I skip this if statement. Oh, in this case, oh, I see. So if you can see here, then I literally just call this if statement. And if it's not that, then I return false. But as you can tell, I literally just appended this first parentheses. Therefore, in that same loop, I'm just returning out. Does that make any sense? Oh, sorry. Good. Okay. So we should do what our for loop of, calling that specific input, then we should put this in an if statement. Oh God. Sorry for the bad intent. Does that make any sense? Because in this case, then if that specific input is a open parentheses, then we should just skip whatever we would do in the next step. Okay, so if my parentheses are correct, this should return true. Okay, and it does. So let's go on to test some more. String, I'll just call this string 1. And anybody want to give me an invalid parentheses? If not, then I'll just type it. And you can just give me the other one. Oh, nice. Thank you, Katie. Insert verify parentheses equals false. If Replit would like to run, that'd be great. Is it running or is it?
Yeah, I think it ran.
Oh God,
Never
please
mind.
stop.
Oh, no. I think it ran normally. Yeah.
Second.
Oh, error.
Wait, I'm so confused. Okay, so apparently is it that I'm doing? How is it possible that I'm going into a segmentation fault? I'm not even like, I'm not even doing anything. What the heck? Let's see. Okay, if anything, unfortunately, I think we're going to be running out of time, but let me debug this and then I'll be right back. Let Bill take over. No, let Katie take over for the second question. Oh, sorry, we're gonna go on break. And then I'm going to debug this hopefully, and then we'll just go over a little bit in 5 minutes. Sounds good? Okay. Pause the recording.
Going into. That's also a great idea. Anyways, so in that case, the data structure that you want to keep track of the squares that you want to visit is going to be either a stack or a queue, right? Because you want a data structure where you can like insert elements and then get, be able to get elements out in a specific order, right? And so again, like this is intuition, starting with the source, check if we're already at the destination. I'm sure you already know all this. I think you can just show the entire slide at this point. Yep. Did the process. Okay, I think we can hop to the Replit right away, and I'll quickly go over the solution. Okay, great. And so what we want to use is this method where we're given a grid, a start x, a start y, an end x, and an end y, and we want to return a Boolean. Okay, great. So the first thing we want to check is to make sure that the grid size is correct. So we can take the n, the size, as well as the m, and make sure that if any of these values are 0, then we can return false right away. Okay, great. And return false at the end. Next, we know that if we are already at the end square, then we can also return right away. But this time, we know that we can solve the maze immediately, and so we can return true right away. Okay. And so one important, I guess, tip that I really like, that I use really often in these types of problems where I want to traverse some kind of grid, is to have a static directions array. And so with this, what I can do is simply loop through like the number of directions that you have and initialize a static array like this with the directions that you want to go to. In this case, the 4 cardinal directions, not including diagonals. And with this, it makes life much easier when you are looking through like a neighbors of squares. And so this saves a lot of headaches later on. And I highly suggest you use this whenever you're trying to traverse like a grid type of thing, which I'll talk about later is really just a graph. And so now we want to define our dequeue. And another important tip is to use like pairs when you want to represent coordinates. I find these are super useful because you don't have to like do some weird way of converting from like one data structure into two coordinates and then back to one data structure. Pairs are like, I find the easiest way to do this. And we want to push the starting coordinates, which we'll make using make pair, into the queue. So we go. Okay. And now we can simply loop while the queue is not empty. And what we can do is we can first pop out the top, sorry. So we know that these are the chords. Sorry, this is going to be front. And we can pop the front. Great. And we can kind of deserialize these chords. So this is going to be X is going to be the first. And Y is going to be second. And we know that, so we want to keep track of spaces that we already visited. And so if you've like clarified with the interviewer that the input grid, you can mutate the input grid, then you can actually use the input grid in order to keep track of squares that you've already visited. For example, if we know that the input grid has elements where 1 represents inaccessibility and 0 represents accessibility, you can pick some other integer value to represent places you already visited. So you can say, hey, like if I've already visited this, then I can set it to -1 instead. And now we can check if the square that we're currently visiting is the n square. If so, we want to return true. And now we can look through all of its neighbors because we haven't returned. And so we can use the directions that we just created earlier. So we simply have to just do a for loop, just loops 4 times over the 4 directions. And we can initialize the new directions. And see, like, I find this much like really, really helpful because it makes looping the directions really easy. And then you can make sure that your new coordinates are within the confines of the grid by doing something like this, where you check if it is like less than 0 or if it's greater than equal to n, or if this is 0, or if this is greater than m. Or if you've already visited it, you don't want to check it again. Or if it's inaccessible, then you don't really care about it and you want to completely ignore it. There we go. And here, you just want to continue to the next iteration of this direction loop. Otherwise, you can simply push it into your queue. So you want to make another pair with XA and YA as the 2 values. Okay, and this should be like your full implementation of the algorithm. And so I would normally advertise and like suggest you guys to make your own test cases, but since we're running out of time, I'm just going to copy paste in my own test cases. I think I have a question from the chat from Trevor. Are pairs like tuples in Python? Yes, pairs are like tuples. I believe in Python, there can be like tuples don't have to be 2 values, like they can be arbitrary. Correct me if I'm wrong on it. But in C++, like pairs are just 2 values. And so if you want more than 2 values, you're gonna have like a more complex data structure. Okay.
Yeah, exactly.
So now,
like what Bill said, tuples don't have to be 2 values, and they could be different data types.
Right, and tuples can be of different types, or like arbitrary types, whereas with pairs, you have to define the types that you want to use. And so here I'm going to take my 2 test cases. So if you want to scroll down to the test cases, Anna, perfect. And so in the first test case, there's a clear path from 0, 0 to 3, 3. While in the second test case, there is no path from 0, 0 to 3, 3, at least one that doesn't involve a diagonal, which we postulated that shouldn't work. And so I've asserted that the first test case should pass, but the second one should fail. And if I run, as long as nothing happens here, looks like it's successful. And so you've solved this problem, which I've solved this problem, which I'm sure you've gone over in CS32 as one of your homeworks. But you've actually come up with and implemented an algorithm that breadth first search or depth first search that is kind of the core of graph traversals, where a graph is made up of like nodes and edges, where edges connect nodes. And I'm sure Natchenberg or Smallberg will go more into this with graphs in the upcoming couple of weeks. But like this is basically the same algorithm that you use to traverse graphs, because a grid can be a node, and each border between two squares is going to be an edge. So great, we're going to pull this to see how you felt about the question and the solution. I'm sure you guys are going to find this really easy because you've all solved it. But yeah, hopefully some of you, it's new for some of you guys. Okay, great. I'll pass it back to you, Anna.
Awesome, awesome. Fortunately, I didn't realize that you guys already did this question. It would be a little bit more challenging if you guys actually hadn't seen this before. That's a good way of thinking about it. But basically, so to conclude, we went over stacks and queues today, and then there's a little bit of a surprise today. We're actually going to be doing mock interviews for the upcoming week, and so I'm going to be pasting a link in the chat below. And so if it takes you to the page right now, like as you can see here, you'll be able to sign up, any times from 15, 17, 18, and then we're going to be opening more times. So be sure to check back, if you don't find a link that you can't find. So sounds good?
Yes, this is something I heavily recommend because like going to these kind of lessons is super helpful, and definitely will give you a leg up over other interviewees. But doing mock interviews is honestly the best way to improve your interviewing skills, just by doing it in front of someone, because like you could have the best algorithmic knowledge and you could be the fastest coder, but if you're not good at communicating to an interviewer or in front of like another human of what you're doing, like you're going to be picked over, someone else is going to be picked over you. So this is definitely like the most important part of succeeding your interviews.
Exactly what Bill said. So I'll give you a little bit of an overview of what you'll be asked to fill out when you are landing on this page. Basically, give us your first name, last name, as well as that email, so we can email you the Zoom link that you'll be getting your mock interview as well. And then we'll be asking you some questions such as what year are you, what courses you've taken, and I marked this one especially like required just because we want to be able to gauge what your understanding is and give you the difficulty of a question that is probably going to be well suited for you. And then as well as how many technical interviews have you completed. And please, everybody, if you are going to sign up for this, please attend and make sure that you do reserve time. And unfortunately, like don't cancel on us. So that's just a forewarning, because last year we did get a bit of no-shows. So we wanted to make sure that if you are going to sign up, you just get a verbal confirmation that you are going to attend. Any questions about what the mock interview process is going to be like? So basically, as you can see here on the left, it's going to be 30 minutes. So I would say it's a pretty standard, like 1 question or 2 question interview, as well as just like, giving you a little bit of time to like introduce yourself. So I would definitely look up and familiarize yourself with like what the interview process of a technical interview screen is like. And then as well as, if you want to practice, you can practice, but if you haven't, like, as you can see here, how many interviews have you completed? We have an option for 0. So if you haven't done them before and you just want to get a feel for what it's going to be like, I think this is a perfect opportunity for you to try that out. Any questions? And feel free to unmute yourself, so it'd be faster for us to answer. And just to reiterate, there's going to be more times than what's listed right now. It's just that, what's it called? I think we still have to work out, like maybe some people aren't available, at night. They're on the other time zones. So if we get any input of people needing some other accommodations, then we will definitely open up times during the day. Very nice. And obviously you can ask us any questions about, I guess, anything else except not about mock interviews, just about today's lecture as well. I guess lecture is not a good word, but anything else you would like. And if you've already done 10+ interviews, good for you. If you want a little bit more practice, we'll happily oblige. Sounds good. And you guys have this link already, right? Okay, I did post it. Sounds good. Okay. Well, you guys are free to go unless you have any questions for us. Thank you for attending, and then we'll be back next Tuesday, I think. Next Monday is a holiday, so be sure not to get up early in the morning. Very nice.